Oh, right, this isn't Darth Vader auditions. No, no. Right, I better get on with what I'm meant to be doing. I'm meant to be delivering space. Right, let me get my notes ready. Let's clear the Darth Vader voice up. Right, yes, my name is Mr. Kanwar, and I'm an Associate Director of Science. Welcome to Outward Space. And these are our first lessons for your Year 7 and 8 on video. So we're removing ourselves from the classroom, as we all are. I hope you're all safe and well. And we are moving to video lessons. Just to let you know, how is it going to work? Well, over the next couple of weeks, you're going to be set 2 videos or 2 PowerPoints with voiceovers, as you can hear, per week. The main part of the lesson is listening and doing the tasks within the video, just as you would do in a normal lesson. Now, they're not going to last an hour long. They're probably going to be between 20 and 35 minutes. After you've completed the video, or the lesson, I should say, you will then be tasked with a Google form quiz, something that you're probably quite familiar with now. And you'll be expected to complete that for Year 7 and 8, particularly for the space lessons. That will be 10 multiple choice questions. Those multiple choice questions will cover the content of the lesson, and then you'll be given 2 extra tasks, one an extension task and one a very, very small written task, just to make sure that you have fully understood the content and being able to apply it. Your teachers will mark that work and then you'll get a mark back from it. So that's how it's going to work. So you're going to get 2 lessons a week. The first one is space. This is lesson 1. So the solar system and planets. Hopefully you know something about it. And as with every outward lesson, we have a challenge and aspire. So first, describe the structure or order of the solar system. I think that's fairly straightforward. And an aspire, compare the planets in the solar system and their orbits around the sun. Right, let us begin. Okay then, so what do we need for today's lesson? Really easy. 1 sheet of paper, pencil and pen, and a ruler. You will need to draw a table. So you can pause this video at any point, and what you will need to do is you'll need to draw the table as I have shown you on the slide. However, do make sure that you have 5 columns and 9 rows. Okay, so 9 steps down and 5 columns across. There are 8 planets, remember. The likelihood is you already know the order of the planets. Even if you don't, obviously this is the point of the lesson that you will find out. So the planet is the first heading. Distance from the sun is the second heading. Length of time to orbit the sun is the 3rd heading. Length of a day is the 4th heading. And relative size to Earth, which is also known as the diameter, is the 5th heading. Do make sure that if you are scrambling around trying to find it now, you can pause it at this point and then you can carry on with the next slide. So Mercury is the first planet within our solar system. It is also the closest planet to the sun, being a mere 58 million kilometers away from the sun. Now, that actually seems quite far, to be honest, but in relative terms it is quite close. So close indeed that it takes only 88 days to go around the sun. That's amazing. So basically within 88 days you would have your first birthday. So that's amazingly quick. And just for some other key facts, it is named after the Roman messenger of the gods. There is a image of Mercury. In the Greek, he's known as Hermes, and he holds that interesting staff, or wand I should say, with the dual serpent known as the caduceus. So if you ever went to a pub quiz, it is the caduceus that Mercury holds as the messenger of the gods. Also, the length of the day is quite a strange one. Length of the day on Earth is 24 hours. Yep. However, the length of the day in Mercury is 59 days. So it takes 59 Earth days for there to be a day on Mercury. And yet it only takes 88 days for it to go around the sun. So, you know, less than 2 days, less than 2 Earth days makes a year. Get your head around that. Less than 2 Earth days make a year. The relative size to Earth, so if we looked at the diameter of the Earth, which is approximately 12,700 kilometers, and if we call that 1, so we call 12,700 1, the relative size of Mercury is 0.4, so it's less than half the diameter. So it's 0.4, less than half the diameter of Earth. So Mercury is quite an interesting planet, as you can see. Very little atmosphere. You can see some large craters that have formed on the surface, and it has extremes. Because the day is so long, there are large parts of Mercury where it's in perpetual darkness and it is really cold. It never gets the sun. And because there's no atmosphere, it doesn't stay warm. So Mercury is an interesting planet. It's our first planet in the solar system, and it goes around, or orbits I should say, the sun in just 88 days. So we move on to Venus. Venus, the Roman goddess of love, as you can see, famous picture there, I'm not sure what I'm saying there, picture I should say. It is Botticelli's fresco. That might not mean much to you, but to be honest, all it is some fancy drawing that was done a long time ago, and you can see Venus being born. Okay, so Venus is the second planet. As I said, it's named after the Roman goddess of love. Now it's just a bit further out from Mercury, and it's 108 million kilometers away from the Sun. So obviously it takes a little longer for it to orbit the Sun. In actual fact, it takes 225 days to orbit the Sun. Now here's an interesting fact. I said before that it takes 24 hours for the Earth to rotate on its axis and for a day to be complete. It takes Venus 242 days for Earth days, that is, for a Venus day to complete. So just think about that. It takes 242 Earth days for one day to happen in Venus. But it takes 225 days for it to go round the Sun. So basically, its day is longer than its year. Mind-boggling. Anyway, that is very strange. It's a very beautiful planet. It is one of the brightest objects that we can see in the sky. Actually, it's quite visible most of the time. It is generally known as the evening or the morning star. The temple that you can see is the Temple of Venus. You can see that in Rome. If you ever were to go, it was built in 121 AD, so a very long time ago. And the size of Venus is very similar to Earth. So the relative size would be 0.9. So that's the relative diameter of Venus in comparison to Earth. So it's very, very similar. You can see it's quite a beautiful planet, actually. It's got some beautiful colours, and that's because it's basically its atmosphere is 96% carbon dioxide. Now, because it's 96% carbon dioxide, that's basically accelerated global warming. If we went through global warming, as Venus did, our planet would end up like that. Can you survive there? Absolutely not. Absolutely not. Because of the global warming aspect of it, the temperature, or the day temperature I should say, gets up to 480 degrees. 480 degrees. Not only would we be crushed by the pressure, but we would boil to death on Venus. Not so much giving out much love there anyway. If in case you have fallen behind in collecting your notes, there are some slides in amongst the planets that are just update slides. This is one of them. So we've done Mercury and Venus. You can see the data that we've collected from the video so far. So if you're keeping your table up to date, this is a perfect opportunity to make sure that you are up to date. Pause it as you wish, otherwise we shall continue. The third planet in the solar system is Earth. So I'm sure we knew that anyway, but Earth is obviously rather special because we live on it. It is able to host life. Another name for the Earth is Gaia. in the Greek. As we're on Roman and Greek gods, we may as well give Earth its Greek name, so it says Gaia. As I'm sure you all know, 365 days and a little bit more that it takes to orbit the Sun. That is one Earth year, and the length of our day is 24 hours. Probably a fact that you probably didn't know is that the distance from the Sun is 150 million kilometres. So we're 150 million kilometres away from the Sun. And it takes, and we'll come on to this in other lessons, but it takes sunlight 8 minutes. This is how far the Sun is away. It takes sunlight 8 minutes to travel from the Sun to the Earth. So if you think about that, on Earth, we see the Sun as it was 8 minutes ago. We'll come back to this kind of looking into effectively the relative past when we talk about stars and the galaxy in some upcoming lessons. But that is something to think about. It takes 8 minutes for sunlight to come. And obviously the reason why Earth is special is because it has oxygen and water. And as far as we know, it is the only habitable planet in our solar system. So Mars, planet number 4 in our solar system, also known as the dusty or the red planet. A couple of features that it has. Mons Olympus, one of the greatest, or the tallest I should say, dormant volcano in the solar system. And it is the planet that we managed to get a probe on, and it's still on there from what I understand. I've not heard of many NASA updates recently, but I believe it's still on there, looking for life previously. Now, length of the day for Mars is very similar to Earth, 25 hours. So it's not really that much different. However, it takes 687 days for it to orbit the Sun. So roughly, if you are 10 years old on Earth, you'd be only 5 years old on Mars, and that's an approximate amount. Now Mars, we think, is quite a biggish planet, but actually it's not. It's second smallest in the solar system. It's actually only half the size. So its relative size to Earth in terms of diameter is 0.5. So it's 0.5, its relative size to Earth, with the orbit of 687 days. It is quite far away from the Sun. It is 228 million kilometres, and it is the last of the inner rocky planets. And what do I mean by that? That means that the 4 planets that we have, Mercury, Venus, Earth and Mars, are all quite small, and they are all rocky in terms of their internal core and mantle. It's rock based rather than gas based, which is when we move on to Jupiter. So there we go, named after the Roman god of war. The temple that you can see, or I should say the ruins that you can see, are that of the Forum in Rome, in central Rome. So Mars was particularly venerated in ancient Rome because he was clearly the Roman god of war. So you can see that he's dressed in a legionnaire's outfit. So there we have Mars. So once again, if you have not caught up with your data, we have Mercury, Venus, Earth and Mars. We have our distance, our length of time for orbit, our length of day, and the relative size to Earth. All those 4 planets, as I said previously, are our inner rocky planets. You may pause this video at this point to catch up if you wish, or you may just carry on. Planet number 5, Jupiter, king of the solar system, and also, as its name suggests, king of the gods, Roman god of the sky and thunder. Interestingly, Jupiter, as much as it's a planet that's really, really far away, in actual fact, 778 million kilometres. I'm just going to put that into perspective before I carry on. 778 million kilometres. Now, the first 4 planets, we've got 58, 108, 150, and 228. So those 4 are between 58 and 228. So they're actually, you know, they're quite equally spaced, around 50 to 60 million kilometres between each of them. And then all of a sudden, there's a massive jump from 228 to 778. So Jupiter is actually 3 times further away from the Sun than Mars. 3 times further away. So the gap between Mars and Jupiter is much greater than the gap between Mars and Earth. Hence, it takes 12 years. 12 years. So as much as some of you who I'm talking to are probably 12 years old, it would take your whole lifetime for Jupiter to have gone round the sun. So you'd only be 1 year old on Jupiter. Now, the length of the orbit is quite long, 12 years. However, it spins, and a day is only 10 hours. 10 hours. That's how long a day lasts. So presumably, if you were to divide it by 2, 5 hours daylight, 5 hours nighttime. It is a humongous planet. 300 Earths could fit in it. However, the relative size to Earth in terms of its diameter is 11. The volume, you could fit 300 Earths of volume in it. However, the diameter is only 11 times greater. I say only, that means it is humongous. You can see there are some features that we all kind of know. The giant red spot, which is a great storm that has been ongoing for 300 years, and you can see the bands. Now the bands you'll see quite a few times on the outer gaseous planets. So we've moved on from the rocky planets now to the gaseous planets, and the reason why you'll see those bands is because it rotates so quickly. The wind speeds are so great, and basically because the wind speeds are so great, we get bands of wind. So they're basically kind of like mini hurricanes or mini storms going across this planet. It doesn't really have a surface, it's just a gas planet, and that's quite a hard concept to get around. So like, is it solid? Could you walk on Jupiter? No, we don't think you can, but that's only a theory. So there we go, Jupiter, 778 million kilometers away from the sun, 12 years it takes to orbit, and the length of the day, that's only 10 hours. So there we have Jupiter. And now we come to planet number 6, Saturn. Quite a mesmeric planet, I feel. If you were to grade each planet in terms of its beauty, Saturn would definitely be one of the top 2. I think most people would either go for Venus as well, because that's got a beautiful cloud structure, it seems. But Saturn, with its rings, it just looks stunning. Now, it's a large planet though, not as large as Jupiter, but it is a large planet, 9.4 times the relative size of Earth. So Jupiter was 11, Saturn's only a bit smaller, 9.4. Now Saturn is named after the Roman god of agriculture and time. Saturn was the father of Jupiter. Now, unlike some of the others, there's a few more. Now I've actually had the great experience of actually visiting the Temple of Saturn, and it is humongous. You can see from the building, it's a humongous one. That's because Saturn was one of the primordial gods, one of the early gods that many people believed in. That temple is in Rome. It's in the Forum. It's right in the centre, actually, known as obviously clearly the Temple of Saturn. Now, Saturn is 1,430 million kilometres away from the Sun. That's quite far. Jupiter was 778, remember? So this is nearly double, 1,430 million kilometres away. So, and unsurprisingly, it takes 29 years for it to orbit the Sun. So actually, some of you sat there will only be a couple of, if it had months, a couple of months old, maybe 4 or 5 months old on Saturn. Even I, the great age that I am, I'd not be even hitting 2 years old, which is great. Well, great to a certain extent, but you wouldn't be expected to be taught by a 2-year-old. So, in terms of the length of the day, we have 11 hours, so it's quite quick. Again, you can see the bands. If you look at the image of Saturn, you can see the bands, the cloud bands, and that's because it spins so quickly on its axis. 11 hours it takes for its length of the day. Some of you might be wondering, where do the rings come from? Well, you know what? Theory, and this is only a theory because we don't have the evidence necessarily at the moment, but theory suggests that those rings were only formed 100 million years ago. Now that might seem a long time ago, but celestially or geologically, it's not that long. 100 million years ago. Why? Well, they seem to think that it was from a previous moon. So a previous moon, through the gravitational attraction of the planet, got too close and literally the planet ripped it apart. And because the planet ripped it apart, it basically disintegrated into small pieces of rock and ice. And that's basically what you can see. So you can see the remnants of a previous moon. Now the gaps in there is perhaps where there are other moons of Saturn, or larger satellites, I should say. These are natural satellites that have basically collected the dust or stopped the dust from collecting. So basically you've got these kind of bands within the rings, and it kind of gives it that allure of being quite beautiful. But anyway, there we go. That is Saturn. So a quick check, we've got Mercury, Venus, Earth, Mars, Jupiter, Saturn. If you've not got the data in that you should have, this slide enables you to just have a quick catch up, pause it if you need be. Let us continue. So we move to Uranus, which is planet number 7 in our solar system, the third largest, also known as an ice giant. It's a beautiful hazy blue colour. The reason why is because most of its atmosphere is hydrogen and helium, but with a tinge of water and methane, which makes it that kind of light sky blue colour. Now, Uranus is named after the Greek primordial god of the sky. That's a fancy word of saying like one of the first gods that ever existed. So he was the father of Saturn and therefore the grandfather of Jupiter, according to Greek mythology. Now, interestingly, he is the only planet named after the Greek gods. All the other planets are named after Roman gods. So he's the only planet, or that is the only planet named after a Greek god. It is really far away, 2,870 million kilometers away from the Sun. It takes 84 Earth years for it to go round the Sun, and it takes 17 hours for it to spin on its axis for a day. So its day, like the Earth, takes 24, it takes 17 hours. Now, because it takes so little time, it has various storms, and some of these storms, and because the pressure is so high, they're amazing. Because of the mixture of hydrocarbons, supposedly there is a rainfall of actual diamonds. So diamonds fall from the sky. We'll never get there, so don't worry about it. You're hardly going to mine it. We're never going to get there. But to have diamonds falling in the sky, because the pressure is so high, it combines all the carbon atoms. So because it combines them, it actually falls as diamonds. So the theory goes. I don't know who's going to ever test it, because obviously, like I said, it's so far away. It's quite large, actually. Uranus's diameter is 4 times that of Earth. So the diameter is 4 times that of Earth. It does have many moons, but most of the moons we think have been captured asteroids, and they've just been caught into Uranus's gravitational field. So, and they've become moons. So the first probe that got to Uranus was Voyager 2, and that was in 1986. 1986. It got to Voyager 2, so that was our first images that we ever got, and that is Uranus. Neptune, the final planet in our solar system, now that Pluto is no longer classified as a planet. I say now, it's been quite a while actually. Pluto's not been classified as a planet, nearly 10 years actually. So Neptune is the final planet in our solar system, a brilliant blue colour, very similar to Uranus in terms of its makeup. So you've got plenty of methane, that gives it, and then that little bit of water that gives it that kind of blue colour. It's even got, you can see those white things, they are actually clouds. That's what you can see, the clouds in there. It has a great blue spot, similar to Jupiter in its red spot, so it's a great storm that it has. And it's named after the Roman god of the sea, known as the brother of Jupiter. You may also know him as Poseidon, but that is the Greek version of Neptune. Beautiful temple, by the way, in southern Italy, Temple of Neptune. Actually, one that's not a ruin like some of the others, although it is classified as a ruin. You can see actually more of it, and you can go to it and visit it. Not my photo, by the way. Now, Neptune, 4,500 million kilometers away. Uranus was 2,870. Neptune is 4,500. So it comes as no surprise that the length of time to orbit the Sun is 165 years, basically nearly double that of Uranus. So you've got 165. However, the length of the day is fairly similar, 16 hours. So the length of the day of Uranus was 17, Neptune is 16. And again, the size is quite similar, 3.8. So it's basically nearly 4 times bigger in terms of its diameter relative to the Earth. So it's nearly 4 times bigger, Neptune. Similar features in terms of Uranus. We've never been to, not many probes have had a close encounter with Neptune, so there's still a lot to learn about it. But it's got some interesting moons that are either captured or previously dwarf planets, or may have belonged to the real outer reaches of our solar system, something that we will discuss in the next lesson about how big our solar system is and what's after Neptune. Now we know Pluto's after Neptune, but there are other things after Pluto even. So it'll be interesting to talk about that. So there we have Neptune. So we come to the end of our journey of the solar system. We've gone through our 8 planets, and you can see my very easy method just speeds up naming planets. Now, it does say planets at the end, because that would have been for Pluto. However, we've gone through Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. The final slide after this is a summary slide. It has all the information that you require or should have collected during the lesson. You are now going to have 3 tasks. So basically, we have gone through the information. I have got 3 tasks for you. The first one, relatively straightforward. Answer 10 multiple choice questions that follow this presentation. Now, today's date is Monday, the 27th of April. You'll have exactly 1 week. So you'll have 1 week to complete those 10 multiple choice questions. For many of you, this isn't any different. It's just on Google Forms. You'll be finishing those, and it'll be multiple choice. So choose the right answer, and hopefully you'll be able to get those right. Your second task is to create your own mnemonic. Just as I have just said, my very easy method just speeds up naming planets. That is a mnemonic. So that basically the first letter of every single word stands for the first letter, or equates to the first letter of each planet. So we'd like you to come up with your own one. I think that's quite a nice activity. See what you can come up with. I must remind you, you must keep it not rude. So let's have sensible options, please. So you can create your own mnemonic, and if you've got a bit more time, but I'd encourage you to do so. How old? Task 3, which is an extension task, a bit of numeracy. How old would you be on Saturn if you were 80 years old on Earth? So what you would require for this is to know how long it takes for Saturn to orbit the Earth. The Earth, oh my goodness. We're talking some geocentrism. Now that is a term you could go and look up, geocentrism. Planets do not orbit the Earth, as I've just said incorrectly. They orbit the Sun. However, many years ago, actually a couple of hundreds of years ago, they did believe that planets used to orbit the Earth. So, easy mistake to make. Anyway, so they are your 3 tasks: multiple choice, create your mnemonic, and a bit of numeracy on how old you are on Saturn. Now you have 1 week to complete it. The second lesson will go online, if not already, on Wednesday the 29th of April. That is moving on to the formation of the solar system. So that's our next lesson. I thank you for listening. I hope it was informative. I hope you have learned something new, if nothing else. And I've enjoyed your company, even though I can't see it. So until next time, goodbye.